Good morning. This is a quick presentation of the integration of one particular functionality of fanten web application with haddock, funded by the Westlife European project. Fanten stands for Finding an Isotropy Tensor and supports many types of operations in the fitting and the analysis of paramagnetic data, in the particular case of pseudo-contact shifts and residual dipolar couplings. First, the user needs to upload the PDB file of the protein that must contain at least one reference metal. Second, the user needs to upload the experimental restraints measured for that protein. The restraints can be provided in both Cyana and Explore formats. Let's choose Cyana format in this case. Third, the user needs to choose the action from the panel. In this case, we are interested in performing a rigid body minimization. Rigid body minimization supports the calculation of the optimal rearrangement between two binding partners or domains in order to obtain the best agreement with experimental data. This functionality permits the upload of a second protein and a second set of experimental restraints. Let's click on Upload and start with the calculation setup. There is a first section where the general parameters can be changed, such as temperature, lipid-Szabo order parameter, and the Euler angle convention and bond lengths. Moreover, the global weight of each restraint can be changed. Rigid body minimization can perform also grid search analysis that is useful in the case of more problematic data. The uploaded experimental dataset can be associated one to the other, and a reference metal can be chosen from a list of metals present in the PDB files. In this case, PCS and RDC have been collected from two different metals. Click on Perform Action to start a calculation. Two tabs will be created containing the results obtained for each metal. Fitting of each data point can be evaluated through an interactive correlation plot. Tensor parameters are reported, together with the transformation matrix, to apply to the second PDB file to obtain the best fit of experimental data. Fitting of the individual experimental data are listed in tabular form and ready to be downloaded together with the tensor parameters and with the minimized structure. At this point, in order to maximize the interaction between the binding partners, haddock can be invoked to perform a refinement calculation. The operation is very easy. The user must insert username and password. In the case in which you are not a haddock user yet, please register to it. Once you are a registered user, clicking on Login will automatically send the refinement calculation to haddock, and after a while you will receive an email with the results of the refinement operated by haddock. Finally, results of the refinement calculation are ready to be analyzed. In this case, a single cluster has been found, and the four structures having the best haddock score can be downloaded and visualized using a molecular visualization program. Thank you for your attention.